Going to talk about solutions, and solutions is covered in chapter 16 in your textbook. And before we start talking about the two concepts that we're going to take out of this chapter, we need to define a few concepts. The first thing we need to remember, what is a solution? And we covered that at the beginning of the year. A solution is really the same thing as a homogeneous mixture. And a solution is made up of a solute and a solvent. So you have the solute is the substance that is present in the smaller amount, versus a solvent is the substance present in the larger amount. So for example, if I have 10 milliliters of vinegar and 150 milliliters of alcohol. Well, I have 10 milliliters and I have 150 milliliters. The 10 milliliters is smaller than the 150, and they're both mixed up together. Therefore, my vinegar is my solute because it's present in the smaller amount, and my alcohol is the solvent. The question is a solution always a liquid? Well, in high school chemistry, most of the solutions you are going to encounter are going to be liquids, and most likely the solvent's going to be water. But it's worth noting that you can have solid solutions such as alloys. So you have mixtures. So alloys are solutions because they're mixtures between two or more metals, or even one metal and a non-metal. Gases such as air, for example, is a solution. If we examine air more closely, air is made up of 78% nitrogen, 21% oxygen, and 1% argon, CO2, H2O, plus a bunch of other stuff. In the case of air, well, air is a solution. Yes, it's a gaseous solution. What is my solvent? Well, my solvent, again, the solvent is the substance present in the larger amount. And since nitrogen is the one that's present in the larger amount at 78%, then this is my solvent. And these guys over here are my solutes. So here, in this case, I have more than one solute. So you cannot work with solutions unless you define what a solution is and make sure that you know that a solution is made up of a solute and a solvent, where the solvent is the substance present in the larger amount. You can also have a solid solute and a liquid solvent, like salt and water. You can put a little bit of salt in tons of water. Well, the solute is solid and the solvent is water, and you can dissolve the solute in the solvent. So that's also another option. So with that said, that just introduces us to the term concentration. So I'm going to give you the general definition of what a concentration is. So really, a concentration is the amount of solute over the amount of solution, or sometimes solvent, depending on what type of concentration we have. Okay, so again, this is the general term. This is the general definition of what a concentration is, but there are many types of concentration. We can have a percent by mass, percent by volume, percent by mass over volume. We can have a PPT, ppm, that's parts per million, parts per trillion, parts per billion. we can have molarity, molality. There are a lot of different types of concentrations, and each one of them follows this very same general definition, but it's being more specific. Because if you think about the word amount could be moles, could be grams, could be volume, could be liters. So there is a variety. So that's why I say that concentration here is really the general term. But what's common between all types of concentrations, it's that you have the part and the whole. Okay, where does the part stand from the whole? So the concentration we're going to focus most on here, or the only one we're going to really focus on in this chapter, is molarity. So molarity, its definition, of course, follows the one that you have on top, but it's more specific. Because in molarity, when we talk about the amount of solute, we really talk about the number of moles of solute. And when we talk about the amount of solution or solvent, we're really talking about the amount of solution in terms of volume. So that's why when you look at the definition of molarity, it's number of moles of solute over liters of solution. Okay? So that's the general, that's the equation for molarity. And the unit is either big M or moles per liter. Personally, I prefer to write it as moles per liters, not to say that big M is wrong, but I like it because it helps you guys when you're doing dimensional analysis to see how the units cancel. That's the only reason why I prefer moles over liters. Okay, so we can just go ahead and do an example right now on molarity to see how you can solve for that. So I have an example here for you. So if a solution of salt water is 1.5 molar and has 6.8 grams of NaCl, what is the volume of the solution? So in this case, I'm going to just go ahead and okay, we already know that molarity is equal to number of moles of solute over liters of solvent. Okay, do we have the molarity of the solution? Yes. What are we supposed to find? The volume of solution, right? So we're supposed to find this. So now, what about this? Are we given the number of moles of solute? Well, first of all, let me ask you, what is the solute? Solute is what the guy that's present in the substance that's present in the smallest amount, or the smaller amount. If a solution of salt water is 1.5 molar and has 6.8 grams of sodium chloride, well, sodium chloride has to be the solute because it's salt water, so it looks like salt is in water. So sodium chloride would be my solute. Well, I have the grams of sodium chloride. Can I find the number of moles of sodium chloride? Well, yeah. You know how to do grams to moles, right? So once I convert the grams to moles, I have that. Then I'm going to solve for the liters of solution. So I can rewrite this as liters of solution. Oops. Is equal to number of moles of solute, which we will figure out in a minute, over molarity. So let's calculate the number of moles. So number of moles of NaCl is equal to 6.8 grams And since we have the grams on top here, so we have grams of sodium chloride down here and moles here. So technically we're dividing by the molar mass, and the molar mass is 58.44. I just happen to know it, but you can always double check that. And when you do the math on this one, 6.8 divided by 58.44, I get 0.11635,866. That's what the calculator is giving me. And these are moles of NaCl. And of course, we do sig figs in scientific notation. If I have 2 sig figs here, then the answer should have 2 sig figs. So really have 1.2 times 10 to the negative 1 moles of NaCl. So what do? You plug this number in here. Okay? So therefore, liters of solution. So I'm just going to do this. So liters of solution is equal now to 1.2 times 10 to the negative 1 moles of NaCl divided by the molarity, which is 1.5 moles per liter. I like to use this unit because you know what? You can see that you're left with the unit you're looking for. So I'm going to take that, divide this by 1.5, and it gives me, I have 2 sig figs, so 7.7 times 10 to the negative 2 liters, which is also 77 milliliters. Okay, so that's an example of molarity. All right, now let's move on to the next concept, which is dilutions. And by the way, I posted a lot of videos, a couple of videos on molarity and a video on dilutions. So I hope you will find this helpful. So with dilutions, we always start with a solution that's really highly concentrated that we call stock solution. So stock solution. This is a solution that we usually buy at suppliers, and we dilute it to whatever concentration we want to use in the lab. We usually don't use stock solutions straight from the bottle as they are. We usually dilute them. Stock solutions are very concentrated solutions. Okay, so let's say, I don't know, let's say we have 1 liter of this, and that this is 12 molar. This is really very highly concentrated. And let's say what volume is needed from a 12 molar solution to prepare a 2.00 liters of 0.15 molar solution. What's going on here? So let me explain. I have this solution over here, and I want to take a little bit from the solution to dilute it to prepare a solution that is 2 liters, but that's only 0.15 molar, so I don't need 12 molar. That's a lot. So what do? I usually, when you prepare this, you add water. So I add water to make it 2 liters, okay? So I take an initial volume from here to prepare a solution that's 2 liters and has this concentration. So how do we do that? Okay, well, here's what you do. To do dilutions, we do M1 V1 equals M2 V2. Usually this is before dilution, and this is after dilution. And I want you to notice something. When you do M1 V1 equals M2 V2, you're really taking the molarity of the first solution, which in this case is our stock solution. So molarity is moles over liters times a volume, right? And volume is in liters. And when you look at that, that's number of moles. So that's going to be equal to a certain number of moles. If I look on the other side, molarity again is moles over liters times of V2, which is volume in liters. You're left with moles. What does this mean? It means the molarity times volume is always equal to number of moles, but it also tells me that the number of moles before the dilution is also equal to the same number of moles after the dilution. Well, how come? Well, let's think about that. If I take a certain volume from here, this certain volume will have a certain number of moles of my solute. And what am I doing to dilute it? I'm adding water, but I really have the same number of moles. The number of moles will be diluted. It will be contained in a larger volume of solvent, but you will have the same number of moles. Okay, let's solve this problem and I'll go over that point again. So basically what this problem says is that I have M1 is equal to 12 molar, that I'm looking for V1, which is X. I know that M2, the second molarity, is 0.15 molar. And I know my second volume, or I want to prepare a solution, that is 2 liters. So really what I do is I'm going to isolate V1. So V1 is going to be equal to M2, V2 over M1. So let's just plug in the numbers. M2 is 0.15 molar. The volume is my unknown here. No, wait, V2. It's V2. No, it's not unknown. V2 is 2 liters. And then M1 is 12 molar. The moles per liter cancel out, and I'm left with liters. That's what I want. And now you do the calculation. So 0.15 times 2 divided by 12. And the volume here is 0.025 liter, which is 2.5 times 10 to the negative 2 liters, which really is 25 mils. What this means, if I take 25 milliliters of this and add 2 liters and add water to make the total 2 liters, I will have prepared this number, this molarity in my solution. Let me explain again. If I do M1 V1, which is equal to, what's M1 again? 12 molar, 12 moles over liters, times V1, and V1 we found it to be 0.025 liters, right? Liters cancel, so times 12. So how many moles do I have? I have 0.3 moles of my solute. Okay. If I look at M2 and V2, M2 is 0.15 molar, or I can do moles per liter better, so you can see how the units cancel, times the volume, which is 2.00, right, liters, yeah. And you do this on the calculator, and it also gives you 0.3 moles. Do you see how the two numbers are equal? Well, why? Because what you're doing, I'm taking 25 mils of this. This has 0.3 moles of my solute. And then I take those 0.3 moles and I add water to them to bring the volume to this, and therefore the molarity is done. Okay. All right, you guys, if you have any questions, let me know. I also, again, as I said earlier, posted a couple of videos on molarity and a video on dilution, and let me know if you have any questions. All righty? Thank you.